So slip in FCC is pretty straightforward. There's only the one close-packed plane that one has to deal with, and that's the 111 plane. But in hexagonal close-packed materials, there are a number of different slip options on different planes. So I'm going to discuss the four main ones right now. Let's start. Here's a hexagonal cell. What we have here is it's an ABA stacking, and what we have here is on a basal plane we have the option to slip by two partials, 1, 2, and that moves us from here to here, 1, 2, 1, 2, and in that sense it's identical to the FCC. So slip on a basal plane in hexagonal is identical to HCP. But we have other planes in the hexagonal lattice that are also have to be considered. This one is the corrugated 101 plane, the prism 1 plane, and it's the same Burgers vector in terms of a slip going from one atom position to the next, but it happens in a direction which is parallel to the one plane and also the basal plane. So again, you may want to be thinking about difference between screw and edge dislocations. A screw dislocation can glide on this plane, which is the basal plane, and also glide on the prism plane. So there's options here for cross slip. But basically, the shear operation of a slip is a fairly straightforward one and involves no intermediate partial positions, although there's kind of a metastable position that no, there isn't. There's no metastable position, it's just prism slip. And then the most interesting plane is the 101 is a pyramidal plane, and that's one which is inclined. I think I showed you a model earlier, and that the planes here that are inclined to the basal plane. You can see them here. We're looking along the pyramidal planes. So when we deal with the pyramidal plane, C plus A slip moves one atom gives you a lattice translation from here to here, and that's a C plus A direction. You have a C up and an A across. So in this case, there are three partials involved: 1, 2, 3, 1, 2, 3, 1, 2, 3. In another video, so this is kind of an interesting slip system because of the three partials that are involved. And what that means, actually, because of the partials on successive planes, we have the option then for twinning on this plane. And I'll talk more about that in another video.